Lesson 3-4 on exponents found on page 70 and 71 in your textbook. So make sure your books are out and your spirals are there with your headings on them. Okay, we're going to start today with our objective, which is that you can use exponents to write large numbers. Okay, then we go back into the textbook at the top and it starts out with your question, how can you use exponents to write large numbers? They give you the thing there. It says a box of cubes has 5 layers. Each layer has 5 rows with 5 cubes in each row. So there are 5 times 5 times 5 cubes in the box. It says you can use exponential notation to represent repeated multiplication of the same number, such as 5 times 5 times 5. Follow with me to the top of page 71. Here they now give us our new vocabulary to look at this week. It says the base is the number to be multiplied. Then it says the exponent is the number that tells how many times the base is used as a factor. So underneath there, you will see the factors there are 5 times 5 times 5. The base becomes 5, and you see the little number 3 there is the exponent. Okay, so let's take a minute and get that information copied down into your spirals. The base here is the number to be multiplied. What number were we multiplying? 5. Good. The exponent is the number that tells how many times the base is used as a factor. That's the little number in the upper right-hand corner. Okay? So here now we're going to jump into the 3 ways. It says numbers involving exponents can be written in 3 different ways. Okay? Exponential notation is where you're going to just write the base and the exponent. So the base that we just saw was 5 because we were multiplying 5. And how many times did we multiply the 5? 3. Good. So the base is 5 and the exponent is 3. That's considered your exponential notation. Okay, another way to do it, number 2 here, is called expanded form. And that shows how many times the base is multiplied. So the expanded form here is 5 times 5 times 5. You take that base and multiply it by the number the exponent tells us. That's your second way, is expanded form. Now your last and final way is what we call the standard form, which means you need to solve for that. So we need to do 5 times 5 first, which gets us 25, and then multiply it again by 5 to equal 125. Okay, so again, standard form is solving that, and your end answer there would be 125. Again, all of this is at the top of page 71. Okay, so again, the base is the number we're multiplying. The exponent is the number that tells us how many times to multiply our base. Okay, let's move to the other examples on page 70. You will see in the upper left-hand corner there, it says exponential notation. It says write 4 times 4 times 4 in exponential notation. That means we need to determine what number is our base, and that base tells us what number we're multiplying. So here in 4 times 4 times 4, what are we multiplying? 4. Good, so 4 becomes our base. And how many times do we multiply this 4? 1, 2, 3. So the 3 becomes my exponent. So the exponential notation, and that's a horrible 3, make sure you have a good 3 and 4 in your notebook. So our exponential notation is 4 to the 3rd power. Okay, now another example there, it says now take and write 10 to the 4th power in expanded form. Okay, expanded form told us to write out the multiplication problem. So we have 10 to the 4th power. What is our base? 10, good. And now this number 4 tells me how many times to multiply it. So how many times am I going to multiply it? 4 times, good. So we do 10 times 10 times 10 times 10. That is your expanded form. Okay, last one here. Different examples. Standard form. It says take and write 2 to the 5th power. I had to rewrite it here in standard form. So finding standard form means we need to solve this. So I need to take 2 times 2, which equals what? 4. So that's taking it. This is once, this is twice. Times 2 equals 8. That's 3 times, because this is telling me to do it 5 times. Okay? Times 2 equals 16. So that's 1 times, 2 times, 3 times, 4 times, and then 16 times 2 equals 32. That's our 5 times. Okay, so 2 to the 5th power in standard form is 32. Okay, now those were the other examples, and right underneath there, there's a paragraph where it says an exponent is called a power, and power is highlighted there. It says you can read 4 to the 6th as 4 to the 6th power. The second and third powers have special names. It says, so read 3 and the little 2 there, 3 we could say to the 2nd power, but they say or 3 squared. And squared is a number that we need to become familiar with. It then says read 6, and 3 is the exponent as 6 to the 3rd power, or can we read it as 6 cubed? Okay, so all of these, again, I wrote down how can you read exponents. Let's get this in our notes. An exponent is called a power. So we would say 4 to the 6th power, or whatever that number is, we could say to the power of. So it's read 4 to the 6th power. If this was a 5, we could say 4 to the 5th power. If this was a 12, we would say 4 to the 12th power. So whatever that exponent is, that's the power. Now, whenever you see the 2 and the 3, those have special names. Now, you can say 3 to the 2nd power, and that's fine, but you might not see that in examples or questions. You're going to see 3 squared, and that means that the exponent is 2, okay? And 6 cubed, okay, is read 6 cubed. You can say 6 to the 3rd power, but you might see it labeled as 6 cubed. So anytime we see the number 2, we want to say squared. Anytime we see the exponent 3, we would like to say and read it as cubed. Okay, good job. If there's any questions, take a minute and put it down.